Alright, welcome to section 1.6, which is set operations and compound inequalities. Alright, so we have the intersection and union of sets. There's two symbols. We have the union, which think of a big U for union, and then we have the other symbol like this, which would be for intersection. Okay, so the two different things. If we have, let's say, two sets, A and B, and a set might be a collection of numbers or something, like that, and so on. That's just an example. If I do the union of A and B, think of what union means usually, like for example in marriage. Usually in marriage, a union between two people, you bring everything from both of your lives together. You combine them all, right? So A union B is going to be everything from A and everything from B. Now intersection is different. If I take the intersection of A and B, I like to think of intersection as just sort of a friendship between these two sets, right? So in a friendship, you don't share your entire life with a person, right? You might have a buddy you go golfing with, a buddy you go out and, eat at restaurants with or something, just different buddies for different occasions. So it's only things that you share in common. That would be the intersection. So just be the things in common. Okay, so that would be the intersection or the union of two sets. So this is union because of the capital U look, and then intersection is the other one. Alright, so let's take a look at example 1. Complete the following. Given the three sets, we have A is 1, 2, 3, B is 0, 2, 4, and C is 4, 6, 8. So A, we're talking about union B. So union, we think of marriage. That means everything from A and everything from B, we're going to plop it in. The order doesn't really matter, but usually I like to put it in numerical order. So we have 0, 1, let's see, so we took away 0, 1, 2, ooh, they both have a 2, but we don't have to write it twice, we can just write it once, 2, 3, and 4. Those are the items they share in common. Or sorry, those are the items entirely, because it was union. So try B by yourself and check in with me. Alright, so B is B union C, so that means everything from B and everything from C, we'll just combine them. So 0, 2, they both share 4, but we'll just write it once, 6, and 8. And there we go, B union C. A intersect B. So intersect, that's just talking about what they share in common. Kind of like friends only share certain hobbies in common. So A and B, what do they share in common? Well, A has a 1, but B does not. Okay, they don't share that in common. A has a 2. Ooh, B has a 2 as well. A has a 3, and B does not have a 3. So that is it. So the only thing they share in common is 2. So just go ahead and write 2. Now the next one is A intersection C, or A intersect C. Go ahead and erase this. So what do they have in common? Well, A has 1, and B does not have 1. A has 2, B doesn't have a 2. A has 3, B doesn't have a 3. You know what? These guys have nothing in common, so what would our answer be? Well, there are two options. We could do this. Oops, let me fix that. We could do empty set. They have nothing in common. Or you could do this. Once again, please do not write that because this is actually a set with the empty set in it. Okay, so this is not correct. Choose one or the other for your answer. Once again, please do not use this symbol when writing 0 in math because I will think you're writing the empty set. Make sure to use a nice 0 symbol. Alright, example 2. Solve the following compound inequalities. Graph the solution and answer in interval notation. Alright, so basically you're going to work with this as you would with normal inequalities. And then you just graph the two together and see where they intersect or not. So we have to be careful here though. What is the term on the inside? We have the word and. Let's go back to the beginning. There are two options, union and intersection. And we have two other terms for union or intersection, the term and or. So for union we use or, and intersection we use and. So if you see and when you're talking about two inequalities, you're thinking of intersection. If you see or when you're talking about inequalities, you're talking about a union. So in example 2, we have the word and, which means we are going to be talking about intersection of these two sets. Before we worry about that though, let's worry about getting the variables by themselves. So we have x minus 2 less than or equal to 5, and x plus 5 greater than 9. Go ahead and solve these. Okay, so adding 2 to both sides, we end up with x is less than or equal to 7. And then minusing 5 from both sides, we end up with x is greater than 4. Alright, so we have our 2 answers there. But now we want to graph these, because remember, we want and. One thing to note, very important, please rewrite that word at the very end. Okay? You don't need to write it the whole way down solving, just write it at the very end. That is something I will look for in grading. Alright, so here's our graph. Let's go ahead and graph the 2 different ones. So I'll go ahead and stick with graphing this in green. So we have 7 and 4 and 0. So 0, 4, 7. Once again, we just put 0 as a placeholder. Always make sure to graph that. So 7, x is less than or equal to 7. And then x is greater than 4. Okay. And now we're talking about and. So and is where they intersect, which means I'm just going to go where they overlap. And it is right here. Okay, so where do they overlap? Well, they overlap at 4, but they don't include 4 together. And then they go on and on and on until they hit 7, and they both include 7. Alright, there we go. Try B by yourself and check back in with me in a second. Alright, so for B, we're going to go ahead and solve both of them by themselves. Okay, so minus 2 from both sides. I don't have to worry about flipping the sign because I wasn't multiplying or dividing by negative. And then I'll go ahead and plus 10 to both sides. Okay, so, and this was an and. Go ahead and box that. Then let's do our graph. So we have 0, 3, 12. I don't worry about spacing too much as long as I indicate where they are in comparison to 0. Okay, so I got 3 and x is less than 3. And then I have x is greater than 12. Alright, so remember, we're trying to figure out where these guys intersect, because we're looking at an and statement. But you know what? They don't intersect anywhere. So is there an actual answer of where they intersect? The answer is no. So what would our solution be? Well, there is no solution. They don't intersect. So our answer would be no solution. There is no interval notation for this because there is no actual interval where they work. Let's look at example 3. Solve the following compound inequalities, graph the solution, and answer in interval notation. Alright, so let's take a look first at what we have. Are these inequalities? Well, yes, they have the inequality symbol. Are they linear? Yep, x is to the first power. Lastly, what is their compound word going on? That is or. So or is talking about the union. Alright, so let's go ahead and once again solve this. The main thing comes into play when we graph. So plus 2 less than 6 and 6x minus 8 greater than or equal to 10. Okay, I'm going to go ahead solving this one on this side. Let's see. Minus 2, negative x is less than 4. Divide both sides by negative 1. Ooh, when I do that, got to switch that sign. X is greater than negative 4. And, oops, sorry, no, that's an or statement. Oop, caught myself. Or, solving the other side. Add 8 to both sides. 6x greater than or equal to 18. Divide both sides by 6 to get that 18 by itself. X is greater than or equal to 2. Alright, once again, if you ever need help with any of the small in-between steps for solving, please stop by an office hour and ask for help. That's what I'm there for. Alright, let's go ahead, graph this. 0 would be here. 2, oops, we have a negative 4. So negative 4, 0, 2. Once again, spacing is not important, just letting me know where the numbers are. Around 0. Okay, so x is greater than negative 4. For that. And then x is greater than or equal to 2. And I usually float these above the graph, if you've noticed. That is perfectly acceptable for me in my course. Some other professors might not like that, but I am fine with that. Okay, so now we're talking about or. That is where we take everything from either side. Because remember, thinking of marriage, usually you bring everything from your marriages together. And there we go. All of that would be in our solution. So that goes from -4, but we don't include -4, all the way up to, well, infinity, positive infinity. And we can never include infinity, and that is our interval notation. Let's take a look at example 3. Okay, so go ahead, try solve this by yourself and check in with me. So I'll go ahead and just work through the solving. Okay, so subtract 5 from both sides. -2x is greater than or equal to, and then 5 and 11, let's see, that would be 6. Dividing both sides by -2, ooh, when I do that, gotta switch my sign. Greater than or equal to -3. And we have an or going on. And solving the other side. -7 from both. Oh, sorry. That should be a -27 there. And we're going to be adding 7 to both sides. So we'll end up with 4x is greater than or equal to -20. Dividing both sides by 4. It's a positive, so we don't need to worry about flipping the signs. And we get x is greater than or equal to -5. Alright, and graphing this, it's an or statement, so we're going to combine our answers at the end. We have a -5, a -3, and a 0. Okay, graphing the -3. Want x is less than or equal to it. And then graphing the -5, x is greater than or equal to -5. And we are taking or, so or means everything. Well, everything would be, gosh, that's the whole number line. So that's from -infinity to positive infinity. The whole answer, so all the possible numbers fit inside this union. Kind of interesting. Oh, all right, our last example. So it's once again an or statement. So we'll bear that in mind for when we're finding our final answer on the graph. Minusing 2 from both sides. Okay, we got x is less than 3, or we'll go ahead and add 10 to both sides, and we get that x is greater than 12. So we have 0, 3, and 12. X is less than 3, so not equal to 3, just less than 3. And then x is greater than 12, but not equal to it. So for the union, or for or, are we looking for where these intersect, or are we taking everything? Remember, for or, we're just taking everything. So even though these guys don't intersect, we actually do have a solution. It's all of this plus all of that. So how would I write that in interval notation? Well, I'll show you. So we're going to start from left to right. So the starting value would be -infinity. And we go till 3. Pause at 3, but we're not including 3, so we use that. And then we're going to start again later. So how do I combine these? Well, since this is a union, we're going to go ahead and say it's the union of, and then we'll start at that 12 again and go on till positive infinity. So that'll be 12 to infinity, and we're done. Okay, so definitely a good thing to remember. This is what happens if you're using union and the two intervals are so to split. You union their interval notation. Alrighty, that is it for section 1.6. Please email me or come to my office hours if you need any help.